Everyone, in this video we will discuss about the design of shear reinforcement in a prestressed concrete members. For this one we need to refer IS 1343 page number 32 clause 23.4. In this page you may have limit state of collapse shear. From that class you can design with the help of the class 23.4 you can design the shear reinforcement. The ultimate shear capacity, this is the shear capacity. Shear capacity of the structure or the member is the sum of shear capacity contributed by the concrete plus shear capacity contributed by the stirrups. See, ultimate shear capacity equals to the sum of capacity contributed by concrete and capacity contributed by the shear. Now we need to design the shear reinforcement such that after deducting the ultimate shear, after deducting the shear resistance contributed by the concrete from the ultimate shear, right? For this amount we need to design the stirrups or any other shear reinforcement, right? To determine the shear contributed by the concrete, we need to confirm whether the concrete is cracked or uncracked. Whether the concrete is cracked or uncracked. We have one formula for cracked section, we have another formula for uncracked section. Right. Now, if we consider VC for uncracked section, the formula will be VC is equal to 0.67 B times capital D multiplied by square root of FT square plus 0.87 FCP times FT, where B is the breadth of the member, D means depth of the section member, FT is the tensile strength of the section, FCP is compressive force, FCP is compressive stress of concrete at CGC due to prestress. Right. Once we know all these terms, we can determine the shear resistance contributed by the concrete. To determine the FCP, simply we can use the formula prestressing force by area. Remember, always we need to take the positive sign here. Next, if we consider shear contributed by uncracked section, a cracked section, the formula will be 1 minus 0.55 FPE divided by FPK multiplied by tau C BD minus M naught BU by MU. This last term is shear corresponding to moment m naught. Moment m naught. There is a formula for this one. M naught is equal to 0.8 fpt I by y. Right. No need to remember all these formulas. All these formulas will be available here in page number 32 and 33. This formula is available in page number 33, class 23.4.2. The earlier formula, this formula is available in page number 32, class 23.4.1 in IS 1343 2012. Right. This already we know. This total section will start from page number 32. Here, FPE is the effective prestress. FPE is effective prestress after losses. Effective means after all losses. This value should be less than or equal to 0.6 FPK. FPK means characteristic compressive strength of concrete. That is M40 or M20 like that. Right? FPE is characteristic compressive strength of FPK is characteristic compressive strength of concrete. FPE is effective prestress. Effective prestress means prestress after all losses. This value should be less than or equals to 0.6 FPK. Okay. Next, tau C already we know. This is the ultimate shear stress or shear capacity. Ultimate shear capacity we can say. B is the breadth of the member. Breadth. D is depth. D is the depth of the member. M naught already we discussed. Here MU and VU are shear. MU means movement due to ultimate load. Movement due to ultimate load. And VU means shear due to ultimate load. Shear due to ultimate load. Right? Once we know all these terms, we can determine the VC in cracked sections. Once we know VC, to design the stirrups, we need to deduct this value from overall shear. Right? Now, what is the maximum permissible? To determine the maximum permissible shear, maximum permissible shear stress. To determine the maximum permissible shear, or else to check whether the crushing of concrete in a shear compression failure occurs or not. To check shear failure due to crushing of concrete. How can we check it? We can check by using formula VU by BD less than or equals to tau C max. This tau C max can be obtained from table 9. Table 9 of page number 34. Page number 34. Total statement will be available in page number 34. Okay, we can determine the whether the structure will subjected to shear failure due to crushing of concrete or not. Okay, this value always should be less than tau C max. Right? How can we determine How can we determine the area of shear reinforcement? Generally, we provide two-legged stirrups, right? Two-legged stirrups. How can we determine the area of these two-legged stirrups? How can we determine the area of two-legged stirrups? Means you can say ASV. How can we determine? By using a formula. ASV divided by space of vertical stirrups is equal to VU minus VC divided by 0.87 FID. This is not a new term. This is nothing but a VS. This is nothing but VS. From this formula, we can determine the spacing between the stirrups. Okay, ASV we decided. Right? If we are using two-legged stirrups, then ASV will be 2 suppose 8 mm dia. 2 multiplied by pi 8 square by 4 will be the ASV. Suppose if you are using 10 mm dia, then 2 multiplied by pi 10 square by 4. Okay, like that you can determine the spacing. You should remember one thing that as per IS 1343, the spacing should be such that the spacing should be less than 0.75 times the depth or 4 times of width of the web, whichever is less. Right? We will solve a problem. See, I am taking a question. There is a prestressed rectangular girder. There is a prestressed rectangular girder. There is a prestressed rectangular girder of cross section 150 mm by 300 mm. We need to design for the shear. We need to design for the shear, ultimate shear, sorry. We need to design for ultimate shear force of 130 kilonewton. Then we can call it as a VUR. And there is a uniform prestress across the section. Uniform prestress across the section means FCP is equal to 5 kilonewton, not kilonewton, 5 Newton per mm square. And it is also mentioned that characteristic compressive strength of the concrete is 40 Newton per mm square. Right? They used 8 mm dia Fe415 HYSD bars as the stirrups. We need to determine the spacing. That is SV. We need to determine this one. Okay. This is the question. First, what we need to do? We need to determine VS. VS is equal to VUR minus shear resistance contributed by the concrete. VUR is already given, that is 130 kilonewtons minus VC. This is we need to determine. This VC value we need to determine. This is unknown. Okay. VC is equal to 0.67 B times D FT square plus 0.87 FCP multiplied by FT. From here FCP is equal to 5 Newton per mm square given in the question. FT is equal to 0.24 multiplied by root of FCK. FCK is 40. That is equal to 1.518 Newton per mm square. Now, if we substitute all these values in this formula, we can determine the VC value. VC is equal to VC is equal to 0.60. What is the B value? B value is 150. Depth is 300. Root of FT value we have calculated now, 1.518 square plus 0.87 times FCP. FCP value is given as 5 and FT is given as 1.518, right? Then VC is equal to 87,260 newtons, approximately in kilonewtons 87.26 kilonewtons, right? Now VS is equal to, it is VU is 130, VUR is 130. We need to deduct this value, then we got 42.74 kilonewtons. Now we need to design the stirrups for this one. Okay, I am assume 8 mm dia 2-legged stirrups. 8 mm dia 2-legged stirrups. I am using 8 mm dia 2-legged stirrups as the shear reinforcement. Then the area ASV is equal to 2 into pi d square by 4. 2 into pi d square by 4. We need to substitute this value. We will see. We know this formula, ASV by SV is equal to VU minus VUR minus VC by 0.87 FID. From IS 134 we know this one. This value is nothing but VS, right? ASV we know. ASV is 2 into pi 8 square by 4. This we need to determine SV value. VS value already we know, 42.74 into 10 cube divided by 0.87. Fi is 415 and D is 250. From here you can determine the SV value as 212.28 mm. This value should be less than 0.75D. 0.75D is nothing but 250 and 4 times of depth of the web, that is 150. It is 600. It is 187.5. Okay, spacing we got 212. But as per IS 13 we need to provide the maximum of 187. That's why provide 2-legged stirrups at 180 mm center to center, less than this one. I am taking less than this one. 180 mm center to center. This is the problem.